Hello everyone, today I'm going to introduce my research question and the methodology. Before we begin, let me briefly introduce myself. I'm Yu-Ching from Taiwan. One of my hobbies is assembling and disassembling models. This reflects my curiosity about how things work and my enjoyment of taking things apart and then putting them back together. It also help shape my research interest, understanding systems by breaking them down and rebuilding them. Now let's move on my topic. My research question is to what extent does implementing dynamic wayfinding reduce parking search time, total circulation distance per vehicle, and floor occupancy imbalanced compared with the current signage during weekdays, teaching peaks, and special event period at OGGB car park? To answer this, I use a before and after field study with 3 key steps, including operational observation and sensing, user survey, and simulation modeling. We use ceiling-mounted cameras, loop detectors, and Bluetooth or Wi-Fi sensors on each level to track vehicle movements. This instrument capture data such as search time, circulation intensity, throughput, occupancy balance, and queue length at the entrance gate. A QR code surveyed at pay station record drivers' perceived ease of wayfinding, compliance with guidance, and user type. This subjective feedback complements the sensor data by capturing experiences that technology alone cannot measure. Both data sources are then used in simulation model, allowing us to compare results before and after implementation. If installing dynamic signage turns out to be costly, we can also run sensitivity analysis to find the most effective design. We choose a field study rather than a lab experiment because it reveals real operational impact under true demand peaks. A 1-week stabilization period helps reduce novelty and learning effects so we can observe genuine behavioral changes. By combining sensing, survey, and simulation, we gain a full picture, hard data on performance, user perception to explain behavior, and a model to test scenarios that cannot be directly observed. Finally, the model qualifies the improvement as a percentage, help us evaluate the effectiveness of dynamic wayfinding and identify which design contributes most to smoother circulation. However, there are also potential limitations. First, the survey response rate might be low during peak hours, which would bias the perceived feedback. Second, from an economic perspective, installing a system could be expensive and might not always justify its benefits. So that's my introduction to the research design. Thank you for your listening.